Welcome dear student, welcome to my channel Talking Physics with Piyas Sarkar. Previous day we learned about the hydrogen atom electron in lowest state and its corresponding energy and its radius of Bohr orbit and velocity of electron according to Bohr model. So today we shall learn about the atomic spectra or hydrogen spectra. How different spectral line and different spectral series occur and what is their function and some numericals related to it we shall discuss today's lecture. So let us start. Atomic spectra or hydrogen spectra. Atomic spectra. We shall discuss here only with hydrogen spectra because hydrogen is the simplest atom with one electron in its circular orbits and one proton in its nucleus. So it is the simplest form. Now when hydrogen gas is kept in some normal condition, if hydrogen is kept in at some normal condition, if hydrogen is kept, then it does not emit any radiation, But if due to electrical discharge or collision of electron, it emits radiation. What is the cause of it? We know that when an electron, according to Bohr model, when an electron makes a quantum jumps, that is, if this is upper level or excited state or this is ground state, ground state means principal quantum number is 1, n is called principal quantum number and this is excited state. Suppose in this case it is 2. So when an electron goes from ground state to upper state, it can absorb an photon. But when an electron is remaining in the upper state and it comes down to ground state, the radiation comes out in the form of photon. The radiation come out as electromagnetic radiation as the form of photon. But in hydrogen, there are so many excited states and the electron are situated in different state. So due to jump of electron from excited state, to ground state, we get spectra or series of spectral lines. Now, how many series we get? Now, scientist Balmer first found that when an electron, it is the scientist Balmer who first found that electron makes a jump from n equal to 3, 4, 5 and so on to n equal to 2 level. So, we can get a spectral line, a series of spectral line known as H alpha, H beta, H gamma, H of delta. It is the Balmer. As we know that the series structure starts from Lyman, Balmer, Paschen, bracket, P-Funds or Fund series. But the first it was founded by Balmer. Balmer first found that the electron makes a jump from n equal to 3, 4, 5, that is principal quantum number is 3, 4, 5 to n is equal to 2 level. A series of spectral line H alpha, beta, H gamma, delta and so on are founded. So, not only this as founded, and the range of this series is lies from 656.3 nanometer to 365 nanometer, and it is obviously in the visible range. It is obviously in the visible range, and the Balmer series starts from 365 nanometer and its range ends at 656.3 nanometer. If we draw a diagram of Balmer series, then what can we get? This is not energy level diagram but Balmer series diagram. Suppose this occurred at 656.3 nanometer. Then it is 486.2 nanometer. Then it is 434.2 nanometer. Then it is 410.1 nanometer and at last 365 nanometer. So, the gap of spectral line decreases as we comes from longer to shorter. This is longer wavelength, so the gap increases from shorter to longer. This gap also increases, this gap also increases, and so at 653 nanometer we get H alpha. Next we get H beta, H gamma, H delta and H infinity and so on. This is the Balmer series. So, the range of Balmer series stands for 1. And now how we get this value? How we get this value? If you don't see my previous lecture, please search my channel name, that is Talking Physics with P.R. Sarkar, and search spectral line of hydrogen atom. As we know that the value of energy according to Bohr model is, what is the expression of energy? That is m z square e to the power 4 upon 8 epsilon square n square h square 1 by n square minus 1 by m square, or simply you can say it 1 by n f square minus 1 by n I square, where the electron jumps from Ni to Nf level. If this is Ni, I for initial, F for final, obviously Ni is greater than Nf. If electron jumps from Ni to Nf level, but electron here one thing can be considered, that jumps from Ni to Nf level, but in the expression Nf come first, not Ni square minus Nf square. Okay, इसको ध्यान में रखिए. So we can see the expression of energy is mz square e to the power 4 by 8 epsilon naught square n square h square 1 by n square minus 1 by n square. So now this is equal to Hc by lambda is equal to m z square e to the power 4 divided by 8 epsilon square n square h square. Now if we take 1 by lambda, then this h by c is divided through this side. That is h by c is divided, then this term will be h cube, and one c is come here. This term is considered as Rydberg constant. So, the expression for Balmer series wavelength is 1 by lambda is equal to r z square 1 by, for Balmer series always electron comes from n is equal to 2 level. For upper excited state, that is for Balmer series we can put nf equal to 2 and ni equal to 3, 4, 5 and so on. Ni equal to 3, 4, 5 and so on. Here we can take ni equal to start from 3, 4, 5 and so on, and but nf equal to 2. So, this is the expression from Balmer series. Okay. Now, this R is called Rydberg constant. You know R is called Rydberg constant. Its numerical value is 1.0973 into 10 to the power 7 meter inverse, meter second inverse. Sorry, meter inverse, not second inverse, meter inverse. Okay. So, now what is the starting wavelength and ending wavelength? That is, what is the maximum and minimum wavelength of Balmer series? इसको ध्यान से देखिएगा. अगर ये समझ में आ गया तो कोई भी क्वेश्चन आप जॉइंट हो, एनआईटी हो, नीट हो, आप यू आर एबल टू सॉल्व आउट. बेसिक चीज यही है, आपको थोड़ा सोचना पड़ेगा. ओके. इन नेक्स्ट वीडियो वी कैन go with different numericals of NEET, that is the entrance examination for medical. Now, for longest wavelength, what will be the longest wavelength? That is longest wavelength equal to r z square 1 by 2 square minus 1 by 3 square, that is just greater than nf, the starting value of ni. For shortest wavelength rz square for shortest wavelength. Okay, for longest wavelength, this is not wavelength but the inverse of wavelength, that is 1 by lambda. Okay, this value is not lambda but 1 by lambda. Wave number equal to rz square 1 by 2 square, but here ni equal to infinity, 1 by infinity square. So, here we can take ni equal to 3, here we take ni equal to infinity. If we put this value, if we put the value of this quantity, we can get the longest wavelength is 656.3. This is, we can get 656.3 nanometer, and we can get is this 665 nanometer. This is the range of Balmer series. In this way, we can find out any expression. Okay, and for hydrogen, obviously Z equal to 1, so the formula becomes R 1 by 2 square minus 1 by infinity square, and R 1 by 2 square minus 1 by 3 square. Now we can get different series, that is Lyman. If we make a chart, then it will be easiest to learn or understand, and we draw obviously the corresponding, wavelength also, the energy level diagram also. So, here we can say series name, here we take the region in which it occur, and series name is Lyman. The corresponding equation is 1 by lambda equal to r z square 1 by 1 square minus 1 by ni square. Ni takes from 2, 3 and so on. Okay. In which region it occurs? It is in UV region, that is ultraviolet region. Number 2 is Balmer. 1 by lambda equal to r z square 1 by 2 square minus 1 by ni square, where ni starting from 3, 4, 5 and so on, it is in visible region. Okay. Number 3, Passion. 1 by lambda equal to r z square. Obviously for hydrogen atom, z equal to 1. And this model is not only for hydrogen, but all atoms which is like hydrogen atom, that is doubly ionized helium ion or triply ionized lithium ion and so on. Okay. For helium ion, z equal to 2, for lithium ion, z equal to 3. That is 1 by 3 square minus 1 by ni square, and it is okay, here ni equal to 4, 5 and so on. Bracket BR. Bracket, that is 1 by lambda r z square 1 by 4 square minus 1 by ni square. Ni comes from 5, 6 and so on, and the last series is Fund series. P is silence reward, P fund we can write, but we can only uttering that fund. 1 by lambda equal to r z square 1 by 5 square minus 1 by ni square. Ni comes from 6 and so on. These three regions, that is Passion, bracket and fund, this three region is falling into infrared region. So, Lyman series falls into UV region, Balmer series falls into visible region, and these three series will fall in infrared region. So, if we draw the energy level diagram, what we get? अगर आपको मेरा पढ़ाना अच्छा लगता है तो प्लीज़ सब्सक्राइब कर दीजिए मेरे चैनल, क्योंकि और भी अच्छे वीडियो में लाऊंगा नीट, जॉइंट और एचएस के लिए। ओके। और आपको अगर कोई चीज़ समझ में नहीं आए, अगर आप पढ़ना चाहते हैं मुझसे कि सर ये टॉपिक ज़रा बोल दीजिए या डिस्कस कर दीजिए, तो प्लीज़ कमेंट कर दीजिएगा। सो now we go for energy level diagram of atomic spectra of hydrogen. Energy level diagram of atomic spectra of hydrogen. This is the ground state. N equal to 1 and this is n equal to 2. n equal to 1 and 2 का डिस्टेंस ज़्यादा होगा क्योंकि En is inversely proportional to 1 by n square. n जितना बढ़ेगा En का वैल्यू उतना ही कम होता जाएगा. n equal to 1, the gap is n equal to 2, but जितना अपर में जाएगा ये गैप डिक्रीज हो जाएगा. एनर्जी इंक्रीज होगा, वैल्यू ऑफ एनर्जी इंक्रीज होगा, बट एनर्जी लेवल गैप डिक्रीज होगा. ये समझ में ना आया है. पुट इट इन योर head that if increase n, the value of principal quantum number is increased, then the energy level gap is decreased, but the value of total energy increase. Okay, increase n, total energy increase, gap decrease. N equal to 1, n equal to 2, n equal to 3, दिस इज n इक्वल टू 4 और 5 में और ज़्यादा स्लो हो जाएगा गैप 5 एंड in the upper level they are coincide with each other, this type. Now if n equal to 2 to 1, n equal to 3 to 1, n equal to 4 to 1, n equal to 5 to 1, this gives Lyman series. Okay, n equal to 2, 3, 4, 5 comes to 1 Lyman series. Now अब 2 में आएगा, n equal to 5 से 2 में आ सकता है, 4 से आ सकता है, 3 से आ सकता है. So this is give Balmer series. And the corresponding energy, this is the ground state energy, so this is minus 13.6 eV. eV is the unit of energy. This is minus 13.6 eV, that is minus 3.4 eV. This is minus 1.5 eV, minus 0.86 eV, minus 0.54 eV, and so on. As the sign is minus, so lower value means greater energy. As the sign is minus, so lower value means greater energy. So n equal to 5 से अगर 3 में आएगा, 4 से 3 में आएगा, तो it is called Lyman-Balmer-Paschen series. Okay. 5 से 4 में आएगा तो this is okay. n equal to 5 से और 4 से आएगा तो Paschen series, और अगर 5 से 4 में आएगा तो 5 से अगर 4 में आएगा तो और अपर लेवल से भी आ सकता है, तो इसको कहते हैं ब्रैकेट सीरीज, एंड अगर अपर लेवल से 5 में आता है तो उसको कहता है फांड सीरीज. सो फ्रॉम अपर लेवल टू ग्राउंड लेवल, इफ n इक्वल टू 1 फ्रॉम द अपर एक्साइटेड लेवल, इट इज कॉल्ड लीमैन. फ्रॉम अपर एक्साइटेड लेवल इट कम्स फ्रॉम n इक्वल टू 2, दिस इज कॉल्ड बामर. It comes from upper level to n equal to 3, it is called Paschen. If from upper level to n equal to 4, it is called bracket. And if it comes to n equal to 5 from excited level, it is called Fund series. So these 5 series of spectral line occur in hydrogen spectra. And as we go from outside, the energy gap becomes decreases. But the value of energy, this is ground state energy, this is first excited state energy, second excited state energy, third and fourth excited state energy. Okay. So we go with some numericals that the wavelength limit of P-Fund series is the wavelength limit of P-Fund series. If we consider with the wavelength limit of P-Fund series, if we go with this numericals, that the wavelength limit of P-Fund series, that is the wavelength limit of P-Fund series कितना होता है. So if we go with this numericals, the wavelength limit of P-Fund series, so you can see that the wavelength limit of series is, the value is 1 by lambda equal to r z square 1 by nf square minus 1 by ni square. For series limit, for series wavelength limit, put ni equal to infinity, that is infinity level से n equal to 5 में आ रहा है. Okay. For hydrogen obviously z equal to 1, so 1 by lambda equal to r bracket 1 by 5 square minus 1 by infinity square. Now infinity square is 0, we know 1 by infinity is 0, that is lambda equal to r by 25, that is 25 by r. So if we put this in the value of Rydberg constant in calculator, we get 2278 nanometer. We can get 2278 nanometer. Okay, 227578 nanometer. Next, लिख लिया है इसको। We shall go with the second numericals. The shortest and longest, the ratio, find the ratio। इस टाइप के प्रॉब्लम नीट में आएगा, नीट में इससे ज़्यादा टफ नहीं आएगा, इस टाइप के ही आएगा। सो सबसे पहले अपना बेसिक क्लियर कीजिए, उसके बाद आप लोग न्यूमेरिकल प्रैक्टिस कीजिएगा। फाइंड द रेशियो ऑफ शॉर्टेस्ट टू लॉन्गेस्ट wavelength of Lyman series. Find the ratio of shortest to longest. So we know that for Lyman series 1 by lambda equal to R, Z is obviously 1 by 1 square minus 1 by 2 square. This is, ये क्या होगा, shortest या longest? Obviously longest, so here we take as long. So if we take the value of this, that is 1 minus 1 by 4, 1 minus 1 by 4, that is 3 by 4. So 1 by lambda longest equal to 3r by 4, r is Rydberg constant, and 1 by lambda shortest equal to r into 1 by 1 square minus 1 by infinity square. ओके जब इन्फिनिटी पुट होगा एन आई की प्लेस में तो वो होगा शॉर्टेस्ट। सो इट इज ऑब्वियसली आर, वी कैन गेट इट आर। ओके नाउ शॉर्टेस्ट टू लॉन्गेस्ट, शॉर्टेस्ट टू लॉन्गेस्ट। नाउ शॉर्टेस्ट टू लॉन्गेस्ट क्या होगा? शॉर्टेस्ट टू लॉन्गेस्ट अगर हम इसको इससे डिवाइड कर दें तो 1 बाई शॉर्टेस्ट, 1 बाई लैम्डा शॉर्टेस्ट डिवाइडेड बाई 1 बाई लैम्डा लॉन्गेस्ट। ओके शॉर्टेस्ट टू लॉन्गेस्ट बोला है ना, शॉर्टेस्ट टू लॉन्गेस्ट, दैट इज इसको एक नंबर के 2 नंबर दिए डिवाइड करना पड़ेगा। सो 1 बाई लैम्डा लॉन्गेस्ट डिवाइडेड बाई 1 बाई लैम्डा shortest. So 1 by lambda longest means 3r by 4 divided by r. Okay, so we can get lambda shortest by lambda longest equal to 3r by 4, 3r by 4 by that is 3 is to 4, 3 is to 3 by 4. Okay, we can get 3 by 4. So this is the shortest wavelength and longest wavelength का ratio होगा 3 by 4. I hope you understand this. ये रेशियो हमको दूसरे सीरीज में भी बोल सकते हैं कि फाइंड द रेशियो ऑफ शॉर्टेस्ट वेवलेंथ ऑफ द लीमेन एंड बामा सीरीज। तो इस तरह के प्रॉब्लम में हमको क्या करना पड़ेगा कि हम यहाँ पर अगर शॉर्टेस्ट बोलता है तो लीमेन सीरीज के लिए ये फॉर्मूला होगा और बामा सीरीज के लिए यहाँ पर 2 स्क्वायर होगा, इन्फिनिटी रह जाएगा शॉर्टेस्ट, देन उसको रेशियो करना पड़ेगा। आई होप आप लोग को मेरा यह टॉपिक अच्छा लगा होगा। अगर अच्छा लगा हो तो प्लीज़ सब्सक्राइब कीजिए, बेल आइकन को दबा दीजिए और कमेंट लिखिए कि कैसा लगता है और क्या क्या पढ़ना चाहते हैं। सो आज के लिए बस इतना ही। नेक्स्ट दिन हम नीट के प्रॉब्लम प्रैक्टिस करेंगे, जॉइंट के प्रॉब्लम प्रैक्टिस करेंगे इसी टॉपिक पे। थैंक यू।